Okay, worksheet 23, part 2. This is actually low pass and a high pass using resistance and inductance. So, first thing is the corner frequency for an inductor of 10 millihenries and a resistor of 1.2 k ohms. So if I go to my trusty spreadsheet and resonant frequency, corner frequency for R and L. So my R is 1200 and my L, I gotta go back, 10 millihenries, which is 0.01 henries, because you got to be in henries, so that's 0.01, enter. Gives me a corner frequency of 19, and to make our math easier eventually we're going to call it 19100. So that's my corner frequency, 19100 hertz, or 19 kilohertz, 19.1 kilohertz. Okay, so back to the worksheet. Okay. When you build it, if you can build it, then you want to find the true corner frequency. What happens in a practical circuit is your 10 millihenry inductor will have some internal resistance. So your resistance is not all due to the 1.2 k ohms. You have some resistance from the millihenries, and so your true corner frequency will probably shift a little bit. And so if you were to build this, then you would find the true corner frequency when you are down to 70% of your applied voltage. Then you know you are at the corners. So just like in my last video, I put it in SPICE. Now in my last video I had a capacitor where this inductor was, and this was the high pass side. And I had my capacitor where this inductor was, and this was my low pass side. So your high pass and low pass flips with an inductor. Okay, and the other thing to think about is what is the impedance of your inductor at low frequencies. At low frequencies, the impedance is very low. So you'll get more voltage drop across your R1, so you will get more voltage out at low frequencies. And for me personally, I always have to draw the two, inductor and resistor, and then figure out whether or not it's a low pass or a high pass based on, okay, low frequency is going to do this, high frequency is going to do that. And once I do that, then I can put them in the right order and go. That's how I remember it. So I don't remember, exactly. And I did that before I made the video. On the high pass side, as the frequency goes up, this reactance goes up, so more of your voltage will go out at higher frequencies. At low frequencies, this is basically close to a short circuit, so the high pass will be 0 at low frequencies. So that's what happens here, and we know that it's 19.1, so I have to change that frequency because that's from the last time. And so we're going to do one frequency. I think that's going to show up better, 19100. And so I click OK, and if my spreadsheet's right and I run it, then my voltages should both be about 0.707 on a 10 volt source, or 70%, 71%, however you want to look at it. If you build this in the real world, you would probably have to adjust the frequency a little bit to get to 71% or 7.1 volts because of the actual internal resistance. And in SPICE, you can go in and put internal resistance in your inductor if you wish to. So you have a lot of capability in LT SPICE we're not using. Okay, so now I want to try a decade below and a decade above. And if I go a decade below, I'm going down to 1910. And so my low pass should be very high, close to 10 volts. My high pass should be close to nothing. So I'm going to edit my simulation command and get rid of one of those zeros. And then I've gone a decade. And then I'm going to run it. Low pass should be high, high pass should be low. And so what you see is what we saw in the last one. My low pass is 9.95, my high pass is 0.995, which is less than 1, so it's 1/10 of the input signal, and this is 9/10 of the input signal. And that's 1 decade below. If I go a decade above, then it should reverse. So I'm going to add 2 zeros. Okay, and then run it. And sure enough, it reversed. So my low pass is very low out. My high frequency is very high, almost 10. So that is low pass and high pass with an inductor and a resistor. And so for the last part of the worksheet, I'm asking you to do it. Decade below, remember, is divide the frequency by 10. Decade above means multiply the frequency by 10, the corner frequency. And FC is the corner frequency, which you got to calculate. And so then you can go in and see what they all will be. And that completes that worksheet. And I'll just start a new one for 24. Thanks for watching.